Hello class, today we're going to be talking about arc length and the area of a sector. I'm hoping by the end of this video you'll at least have a little understanding about which formulas you use for arc length and which you use for an area of a sector. First, we are going to talk about arc length. Okay, arc length is that distance or length around a portion of a circle. It's actually that portion of the circumference. Okay, now there's two forms to writing this formula. There is x, which is our arc measure, okay, over 360 times pi times the diameter. Now normally they don't give us a diameter, so I actually prefer to use the formula x over 360 times 2 pi r, where r stands for our radius, because most of the time they'll give us that radius instead. Okay, it is going to be a proportion of our circumference there. Sometimes they give you the major arc, sometimes they give you the minor. Okay, remember that the minor arc is the smaller of the two. So let's look at an example. Okay, here it's asking us to find the length that is bolded. Okay, we're going to express our answer in pi and decimal form. So we're going to keep everything in pi until we get to the end. So here they tell us our arc measure is 75 degrees. So that is our x. Okay, and our radius is 4. And all I got to do is plug that in. So I'm going to put 75 over 360 times 2 pi times 4. Okay, I'm going to simplify that fraction, and you can simplify that fraction by sticking it into your calculator and then hitting the math frac button. Okay, and it'll give us 5 over 24 times 8 pi. I just multiplied 2 times 4 there. Now I'm going to multiply my 8 times my 5, and I'm going to get 40 pi over 24, which simplifies to 5 pi over 3, which will be my simplest form in terms of pi or radians. And all I have to do is plug this specifically into my calculator in order to find my value for my decimal. So I'm going to type 5 pi divided by 3. And when you do so, you get a value of 5.2. Now, if any of this was confusing, please pause the video and go back and re-watch that part. For our second example here, we are given the major arc that we're looking for, but they give you the arc measure for that minor arc of 40. So we have to subtract that from 360 because there's 360 degrees in a circle. So 360 divided by 4, subtracted, okay, from 40, we're going to get that value of 320. Now I'm going to use that as my arc measure, or my x, and the 3 is my radius. So over here I'm going to have 320 divided by 360 times, instead of using the diameter, again, I'm going to use 2 pi r. So I'm going to have 2 times pi times 3. So I'm going to simplify my fraction there on the left, and I get 8 over 9 times 6 pi. Okay, and then I'll combine the 6 and the 8 with multiplication to get 48 pi over 9, which simplifies to 16 pi over 3. Then I'm going to plug 16 pi divided by 3 into my calculators to find my decimal answer, and I will get a value of 16.8. Again, if you're still confused, please pause the video and go back and re-watch parts of the video. Okay, so for this next example, I would like you to try it on your own. Okay, feel free to use x over 360 times 2 pi r. So go ahead and pause the video here and work through this problem. All right, so here you have the problem worked out for you. Hopefully it all went well. If you missed something, please pause this video and look at my work compared to yours and see what you can fix. The next part of this unit is going to be that area of a sector. Okay, the area of a sector is the space contained in a sector known as a section, okay, of a circle. So this is actually the portion of your area, okay? So for the formula, we're just going to use the portion of the circle that we have. So it's going to be our arc measure over 360 times the area of a circle, which is pi r squared. Notice that the area of a sector is going to be this space here within the angle and the arc. Let's look at our first example. It's asking us to find the area of a shaded region. Okay, and we're going to express our answers in pi and in decimal form. We're going to round to the nearest tenth. Remember, the nearest tenth is that place right after the decimal. It's the first one. So my arc measure here is 60, and my radius is 2. So I'm just going to plug that right into my formula, and I'll have 60 over 360 times pi times 2 squared. So 60 divided by 360 is going to give us 1/6 times 4 pi, okay, or 4 pi over 6. If we simplify that, remember those are both even numbers, so we're going to divide both by 2. So we're going to have 2 pi over 3. That will be in our radian form, or pi, okay. And our decimal, we just go ahead and plug 2 pi divided by 3 into our calculator, and we're going to get a value of 2.1 in decimals. Again, if you have any questions, please write them down on the side, and you can ask me in class, or pause this video and go back and re-watch it. For our next example, okay, we're doing the same thing. We're still trying to find the area of the shaded region, and we're still solving for pi and in decimal form to the nearest tenth. Now this time the shaded region is covering from the big major arc there, okay, that space. So in order to get that, I'm going to have to subtract my 120 from the 360 degrees. And when I do that, I get my value for my other angle to be 240 degrees. So that's the arc measure that I'm going to use. I'm going to plug that in for my x. I have 240 divided by 360 times pi times 3 squared. Okay. If I simplify 240 over 360, again, you can do this in your calculator. I'll get 2/3 times 9 pi, okay, or 18 pi over 3, which is going to simplify to 6 pi. And if you plug that into your calculator, you will get a decimal answer of 18.8. Okay. Again, if you are confused at all, please have questions on the side for me. Try stopping this video and re-watching it. For our next example, I would like you to go ahead and try on your own. Please note that you have a 90-degree angle there in the middle. Pause here and give it a shot. All right, we should have gotten a value of 48 pi, or 150.8. If you did not get this correct, please make sure that you remember to subtract the 90 from the 360, because the shaded region was indeed not the angle given to you. Okay, so you had to subtract from 360. Again, in class, we'll try to fix anything that you are not understanding, and I hope you enjoyed my video.